Hey everybody, in this video we're going to talk about solving rational inequalities, problem type 1. But before we get to this problem, let's talk a little bit about what rational inequalities are and what it means to solve for them. So let's begin by graphing this function. When we look at this function, g of x equals x minus 1 over x squared minus 4, we can see that the asymptotes and the zeros of where the function might change might make a difference in where the function is below the x-axis or above the x-axis. When we're concerned about a function being less than or equal to 0, then we're concerned about when the function is below the x-axis or when it starts to hit the x-axis, as in the case of a x-intercept, like right there. Okay? So let's continue to talk about this idea. When we're graphing rational functions, what do we need to look for? We need to look for asymptotes, right? And we need to look for intercepts. So similarly, when we're solving rational inequalities, we're going to look for those as well. The critical values or important values when we're considering rational inequalities are not only the zeros of the rational function, so where the rational function crosses the x-axis, but also the values for which the function is undefined, or the vertical asymptotes. So let's go ahead and go back to the problem that we were going to discuss. Now this problem right off the bat starts a little bit different because we don't have an entire rational inequality. Okay, so what we're first going to do if we have something that looks like this is we're going to put everything into one fraction. So we need to multiply this -2 by x minus 5 over x minus 5, just so we can get a common denominator. So we're going to have x minus 2 times x minus 5 over x minus 5. That's what this reduces down to. So this ends up being x minus 2x plus 10 over x minus 5, which ends up being -x plus 10 over x minus 5. And that whole fraction or that whole subtraction, we wanted to see where it is less than or equal to 0. So the critical values or important points are 1 at the x-intercepts. Where are the x-intercepts? The x-intercepts are where y is 0. So let 0 equal our function, and then when we multiply by x minus 5 on both sides, we'll just have 0 equals -x plus 10, and then we'll get x equals 10 as one of our critical points. Well, let's leave an open circle for now, and then we'll talk about whether it's closed. And then the second step is whenever the denominator is equal to 0, because that's a vertical asymptote. So x equals 5. Now, can I ever plug in 5 and get an output? No, because this is the vertical asymptote. So that's always, those vertical asymptotes are always going to be an open circle. At 10, if I were to plug in a +10 into this portion right here, I would get 0. And my problem says I'm interested wherever it's less than or equal to 0. So at 10, I am going to have a filled in circle. And then very similar to polynomials, I'm going to check points in between my critical values. So let x equal 0. And what I'm going to get on the numerator is negative 0 plus 10 over 0 minus 5, which is a positive divided by a negative. Remember, I'm not really too worried about the values. I'm worried about the signs. So this is going to give me a negative value. So in the interval from negative infinity to 5, I have a negative value. Let's go ahead and plug in 7. Negative 7 plus 10 is a positive over, negative 7 plus 10 is a positive, and then 7 minus 5 is a positive. So here I'm going to end up getting a positive overall. So my outputs, whenever my inputs are between 5 and 10, my outputs are positive. Let's plug in 11. Negative 11 plus 10 is a negative, and then 11 minus 5 is a positive. So overall, I'm going to end up getting a negative. Now, what did I actually want? I wanted the outputs where my function is less than 0. So I wanted the negative portion. So I'm going to have this interval from negative infinity to 5, and then again from 10 to infinity. What does that look like in interval notation? Negative infinity to 5, not including 5 because that's my vertical asymptote and I can't ever plug in 5. And then I'm going to go from 10, because that 10 value is going to give me 0, and I wanted it less than or equal to 0, and then to infinity. So those are the x values that I can plug in to this left-hand side that will give me out a value that is less than or equal to 0.